Okay, welcome to this next video for Chem 161, where we'll look at some Chapter 4 materials, specifically touching on polyatomic ions. Okay, so polyatomic ions are interesting species. They behave as ions, as we've handled thus far, like those from metals or nonmetals. And we handle them as a collection that overall have some charge value. Okay, so there are a collection of atoms bonded together. The bonding will be able to reflect later when we know things about Lewis diagrams and VSEPR to help us look at the architecture there. But for now, we need to memorize the name and the formula for these polyatomic ions. Okay, so let's organize our thoughts there. We'll list the name and the formula for these ions. The ions that we're responsible for memorizing will be listed here. They come from a table in your textbook, table 4.3. Okay, so you'll see that table lists others. The ones that I'm presenting to you here, you need to memorize and be prepared to use very frequently in this course and in follow-up courses like 161 and 162 general chemistry. Okay, so the ones we need to know are the carbonate ion. The carbonate ion is CO3 2-. Okay, so just to highlight, the 2- charge here is associated with the whole structure. The 2- is not only reflecting charge for oxygen, but the overall whole compound formula for the polyatomic many atoms for the ion, polyatomic ion, is overall 2-. Okay, so we handle this just like we would oxygen 2-. We would need to add 2 or more of these if we need to balance charges that are overall larger than that, like a 4+ metal cation. That's the carbonate ion. The next one is ammonium ion. The ammonium ion is NH4 single plus. So again, there are 4 hydrogens bonded to nitrogen. That whole species is connected as one, and the whole thing has an overall +1 charge. This is a cation. Okay, the next one we need to memorize is hydroxide. Okay, the hydroxide ion. The hydroxide ion is OH-. Again, oxygen and hydrogen are bonded, and that kind of paired species of oxygen and hydrogen is overall -1 in charge. That is an anion. The next one is the nitrate ion. This is an anion with formula NO3-. Again, all 3 oxygens are bonded to the nitrogen, and that whole architecture has a -1 charge. Next one, phosphate ion. And this is PO4 3-. 3- charges to the overall architecture of 4 oxygens bonded to a phosphorus. Okay. Another one for us here, sulfate ion. And this one is SO4 2-. Okay. And the last one that we need to memorize is the nitrite, emphasis on the "ite" that I pronounced there for the end, nitrite ion. It distinguishes it from the nitrate ion. This is NO2 single charge -1. Okay, these are the 7 we need to memorize and be very comfortable with. The difficulty here is not only memorizing the formula, but the charge value as well. Okay, so take some time to practice memorizing these. Certainly by doing questions where you need to work with them, like naming, you will also exercise that memorization that you've done earlier. Okay, consult table 4.3 in your textbook if you need another version of this table. Okay, so let's take a look at some examples and see if we can name these. Okay, so we'll start with trying to work with calcium carbonate, and we'll try to write the formula. We'll also try to go backwards, starting with lithium NO3, and we'll try to write the name for this compound. Similarly, we'll go the other way. We'll work with ammonium sulfate and try to write the formula for that. We'll also go backwards, do KOH, and determine the name for that. And our last example will be calcium hydroxide. And we'll try to write the formula for that. Okay, so if you're comfortable, you might try to apply your ionic compound naming rules. We have some new ions to work with in this series, and you should be able to apply the simple naming rules for ionic compounds like sodium chloride to determine the formula, and vice versa, determine the name for the compound starting with the formula. This would be a moment where you can pause the video and try that, and then resume once you have your answers. Okay, so the exercise starts, as you know, making sure we know what we're dealing with as far as ions. So calcium, we see calcium is the 20th element, column 2. This should be very routine for you now. We know that this is a calcium cation 2+. Carbonate is one of the ones we've had to memorize, so we know that that is CO3 and that is 2-. We use the same tricks that we want to make sure that there's electroneutrality when we reflect the complete and simplified formula. So we're going to put these species together, calcium carbonate. And as we've done previously, we can think about dropping down charges and simplifying to the version of the formula that is best. Okay, so when we do this, we would momentarily have subscript 2 and subscript 2, whereas the right subscript 2 that would be here acts on the whole structure. So we're going to need parentheses should a subscript have to be located there permanently. But because we have kind of a 2 and 2 situation here, we are going to leave 1 and 1 as the subscripts, and we do not need parentheses on our overall polyatomic ion that is our anion carbonate. Okay, so simply CaCO3 is the correct formula there. Okay. Next, working backwards, if we're provided with the formula, well, we need to provide the name in words. So we know that lithium, going to the periodic table, is right here. That is a metal. So we are dealing with lithium. We know that is +1. So by breaking that away, we've kind of already determined what the charge value on this polyatomic should be. We've memorized that the nitrate has to come apart all as 1. That's a polyatomic ion. And if it's lithium plus, that should be balanced with the same charge but opposite. So that's going to be minus, and that's exactly what we have. Okay, so the word here, we're going to apply the name of the cation. So lithium ion was the name of the cation. We're going to drop the word ion and continue. And we now need to apply the word for the anion. And so that is nitrate. Okay, so be very careful on the nitrate. Do not confuse nitrate and nitrite. That's a tough one to negotiate. Make sure you've memorized that one carefully. Okay, moving forward, let's move to the next one. We're given the name and we need to determine the formula. We recognize that we have 2 unique ions listed here, both of which alone are not listed on our periodic table. These are both polyatomic ions. One is a cation. The first one is a cation, listed where the metals would normally be. The second is an anion, sulfate, and that is expected to have negative charge. So in memorizing the list of 7 that we have here, we should recognize that we have NH4 single plus, and we have SO4 2 minus for the sulfate. And so now when we write the formula, we have to ensure neutrality. So we can begin by writing NH4 and the SO4. Now in order to neutralize twofold minus charge on the overall sulfate polyatomic, we are going to need 2 of the ammonium species. We are going to need 2 of these to neutralize that. Okay, so we're going to do that and make sure that we do this with a parentheses to show that we need 2 of the whole thing. And if you do not use the parentheses, first of all, your subscripts are going to get close to one another. 4 and 2 might look like 42. Second, it looks like you're only putting the 2 on the hydrogen, if that were the case. So we need the parentheses to show that we're dealing with the whole polyatomic ion ammonium that is twofold in population for every sulfate anion. Okay, likewise working with KOH, going back to the name, well, we've got potassium, okay, right there. So we're dealing with the potassium. We have to realize that K is indicating potassium K, not phosphorus, not P. So be careful there. Potassium K, you'll need to memorize that as well. And recall that we're dealing with potassium there. So potassium ion is the K plus that we have. That's our K plus there. And we've got that combined with one of our polyatomics. This one is the OH minus, the hydroxide. Potassium hydroxide is the OH minus polyatomic anion that we've memorized. Okay, and in the last case, we have calcium hydroxide. We see calcium, again, like we saw in the top example. So this is calcium 2 plus for the same reasons we saw above. The hydroxide we've memorized already, so that is OH minus. We can kind of use our cross-drop tricks and put the 2 there and the 1 there. We're dealing with a polyatomic, so we got to be sure to think about parentheses if we're going to list a subscript here. And so we'll reflect that in our final answer. We will have calcium 1 balancing the overall charge value of OH, and we need 2 of those. So we're going to put parentheses there and put a 2 there, and this is the correct answer. If you listed CaOH2, this is indicating that we've only got 2 hydrogens and we're missing the double contribution from oxygen. We are not showing the 2 doing mathematical work on the oxygen. You need the parentheses there. This is incorrect. Okay, hopefully that practice on naming helped, and we've learned that we need to memorize our 7 polyatomic ions to be better prepared for quizzes and homework in this course.